Hi all, welcome back to Environmental Science 101. Today we're going to talk about pseudoscience, or things that present themselves as science, but really because of the way the information is either collected or the information is presented, it's not a science. Okay, so let's look at some examples of this and why they're not science, and how things might fit into this. And especially in environmental science, there are a lot of pseudoscience topics that fit in environmental science. Okay, so the first thing is it's a different kind of idea than a scientific study. Remember, we talked about before, in order for something to be considered science, you have to be able to test a hypothesis or design a test for a question. You have to collect the data, you have to analyze the data, and then you can present the data. Okay, so pseudoscience are often presented as if it is science, okay, but doesn't follow those scientific principles. Okay, and we're going to talk about the scientific method in just a little bit. When we talk about scientific principles, we're normally talking about the scientific method, and that for something to be scientific, it needs to follow the majority of the scientific method. We'll talk about certain things in the scientific method that may not need to be followed in order for something to still be considered science. Okay, but a pseudoscience, often they're not repeatable or reproducible. Okay, so it might have a claim or an experiment that was done that you just can't, there's no experiment, there's no way that you could redo it. It's a, this happened once kind of thing, and therefore they're claiming it's real, or they're claiming that it's science. But in those cases, because it's not repeatable, it's not reproducible, I'm not saying that it doesn't exist. Okay, that's not my place. But as a scientist, it's not science. Okay. The claim has no experimental evidence. Okay? So sometimes claims will be presented, but there was no experiment. It might be things like, oh, if you drink this material, then you'll never get cancer. Okay? Well, if there's no experiment, and there's no experimental evidence that that material fights off cancer, or that material has shown that individuals that consume this material never develop cancer, then that's not science. Okay? And I'm not here to say that whether or not that is true, okay, but don't claim it's science. And otherwise, a scientist will label it as pseudoscience. Okay, and then one of the big ones that often happens is that there's no alternative explanation that has been tested. Okay? So sometimes things will be presented, hypotheses will be presented, a single experiment will be done. That experiment may or may not be biased, and then there's no other explanations, no other hypotheses, no other experiments done to refute the original hypothesis. And so that's not to say that couldn't be science, but it's incomplete science, and therefore gets labeled as a pseudoscience. Okay? There are many examples of pseudoscience, especially in environmental science, biology, and they can have long-lasting impacts. They can make it so politicians, individuals who make laws or bring legislation to voters are basing their legislation on pseudoscience. It can be policymakers and things like that that have this pre-notion of, oh, I read this story, and it was presented as it was science, but really it wasn't science. It's not following the scientific method. It's not presented in a scientific journal. It's not published in peer review, in which there's other scientists that read it and review it and make sure that the scientific process was followed in order for that to occur. Okay? So not all the time is pseudoscience kind of the wool over the eyes, or not all the time is it blatantly on purpose to deceive people. Okay? I don't want to make that claim. Sometimes it's incomplete science. Sometimes the individuals just haven't done enough. They haven't figured out alternative explanations. They haven't done enough experiments to make it a true scientific project. Other times it is exactly that. It is designed in a way to present itself as if it's scientific. It's not science, and it's there to deceive the public for the purpose of maybe a group or an individual or some belief. Okay, so we can look at an example of this, one that had stood the test of time for a very long period of time, and that's spontaneous generation. Okay? Spontaneous generation, and I don't even feel good about calling it a theory, because theory means that it was tested. It is more like a hypothesis and more like an explanation, but it wasn't even a scientific explanation. But spontaneous generation was this idea. I should call it a social theory. Okay, was this idea that life could spontaneously generate from non-living matter. Okay? And it was an explanation for lots of things. Like if you had, a pile of animal dung or animal feces, okay, and beetles started appearing in it, that was spontaneous generation, that they poofed into existence. Okay, like rotten meat and maggots forming on it. If you had a jar with some rice in it, all of a sudden, next time you come back and there's mice in that jar. All kinds of things. Okay? Diseases were a big one. You get sick, and with cholera or any of the diseases in kind of this period of time, they're all chalked up to spontaneous generation. And many, many times they were blamed on or given credit to a superior being, a god or religion, and that entity made those things happen. God put those maggots on that rotting meat, okay, or that entity made you sick because you are a sinner. These kind of things were the explanations at the time, but many of them were never tested. They were just accepted as spontaneous generation, that things can spontaneously generate from non-living matter. So there, like mice crawling out of a pot, of grain or whatever, spontaneous generation. Now, once science really started to get developed and individuals started to realize that it doesn't seem too likely that maggots will just form on rotting meat, that doesn't seem a likely explanation for what's going on for that natural phenomena, scientists started to question this, and they started to design experiments. They started to design experiments where they'd put meat inside of a closed jar that's capped off, and if you did so, no maggots formed on it. They started, sealing the jar so it was airtight, and what do you know, no mice generated in it. And one of the big ones that came from Louis Pasteur's work is the part of the theory, or part of what we call the germ theory, or the theory of disease, the germ theory of disease. How do diseases happen? How do people get sick? And Louis Pasteur was not going to accept spontaneous generation. He was a scientist. He's well known for pasteurization. Louis Pasteur is his last name. Pasteurization was named after him. So the process by which we heat things like milk to a certain temperature to allow for a longer shelf life, that was invented by Louis Pasteur. But also credited with generating experiments that refuted spontaneous generation. Louis Pasteur generated this by looking at bacteria growth, and so he would fill flasks, which was called Pasteur flask or Pasteur glassware at the time. He'd fill these flasks with nutrient broth that you could grow bacteria and fungi and other things that occur in the atmosphere. You could grow it in it, and in many of the vials he would just break off these long glass tubes, and he'd allow air to flow into these, and over a few days, a little bit of time, they become enriched with bacteria and fungi and other microbes. In some of them, he left these long glass rods and found out that air still can get in, but the bacteria and the fungi, the small microbes, couldn't fight against gravity. Okay, so they couldn't make it up this tube. The air could make it up the tube, but it couldn't carry them up the tube. And he, went years with some of these flasks sitting on his tabletops, on his benches, and none of them would ever develop this cloudy material where bacteria or fungi have invaded that nutrient. And so Louis Pasteur came up with the idea that indeed people get sick from the microbes that are present in the air, and that things rot, meat rots, bread molds because of microbes that are invisible to the naked eye but are present at all time. And so once Pasteur in the mid-1800s developed his research, we start to see less talk about spontaneous generation and more talk about the theory, the germ theory, or the theory of how diseases are passed, and that's due to scientific research. So a lot of times pseudoscience, maybe explanations will start out as an explanation for some natural phenomenon. The explanation is not scientific, and what happens is scientists get a hold of that explanation and they don't accept it because it hasn't gone through the scientific method. So then they'll go through the scientific method and come up with the actual explanation. So not all pseudoscience, I don't want to make it seem like pseudoscience is a bad thing. Sometimes it's just an explanation. That's what happened with spontaneous generation. They didn't know. They had no idea, so they just said things could spontaneously generate. And we now know that that's not the case. Okay, next time we're going to talk about the scientific method.